Swayam Prabha. Digital India. Educated India.
Now, let us do an application of this for an angle section. Let us say the cross section is in the shape of an angle. Okay. So, in the shape of an angle, let us assume that this distance is B, as does this distance, this also B. Let us assume that this thickness is T and this thickness is also T. Okay. Let us assume that thickness is also T. Okay. Now, the axis is, first you have to find where the CG of the cross section is, right. First you have to find the CG of the cross section, CG or centroid of the cross section is something you have to find first. Okay. Let us assume for that initially your y and z axis is oriented like this. This is y and this is the z axis. Okay. With respect to this, I am finding the centroid of the cross section. Okay. Now, I know that for, let me close this, let me assume that I am closing this, and the centroid of this leg of the angle section would be somewhere here, and that would be, let us say that is let us say that this centroid is y leg centroid, and let us say this is z leg centroid. Okay. And for this, now for this position of the leg, there will be another centroid which is here. Okay. So, let us say this is y m c g, z m c g. Okay. Now, the distance of this from this end, the centroid of this leg from this end would be T plus B by 2, right. Okay. And then the distance of this centroid from here to there would be B by 2 plus T. Okay. Now, this position of the centroid, this distance would be T by 2, as does this distance also is going to be T by 2. Okay. So, to find the y centroid, YCG of the cross section, what should I do? I have to take the leg area, that is B plus T into T, okay, times the centroid of the leg region along the y direction. Along the y direction is, this distance is along the y direction, so that is T by 2 as we have estimated here. Okay. So, YCG would be the area of the leg B plus T into T into the y distance, which will be T by 2, okay, plus the area of the web, that is this area, that will be B into T into the y distance from the origin, that is the cornermost point to the center of that will be this distance, that will be that distance which will be b by 2 plus t. Okay. So, we have accounted for two areas and hence the entire cross section divided by total area of the cross section, which will be b plus t into t plus b into t. Okay. Now, I can simplify this equation to be given by, I can cancel a t throughout, so that will become b plus t into t plus b into b plus 2t divided by 2 into 2b plus t. Okay. So, this will simplify to further 3bt plus b square plus t square divided by 2 into 2b plus t. Okay. Now, similarly, let me find the z centroid of the cross section. Okay. Now, what is that we have found? The y centroid, right? What is that? That is nothing but this location, that is centroid of the cross section. This is CG of cross section, okay, and this distance is YCG cross section, okay. And now what we are going to do is move this axis from there to YCG to ZCG, okay. We want to move it to there, okay. Now, similarly, I am interested in finding what this distance ZCG of cross section is, okay, from that end. So, towards that, what I have to do again, I have to find the area of the bottom leg b plus t into t into the z distance of its centroid, which would be this distance b plus t by 2. So, it will be b plus t by 2 plus for the vertical member, for this vertical member it will be plus b into t, which is the area of that member, into its z distance of the centroid, which is this distance in here, that is this t by 2 in there. So, into t by 2 divided by b plus t into t plus bt, okay. So, this again I can cancel the t throughout and this will become b square plus t square plus 2bt plus bt divided by 2 into 2b plus t, which is nothing but same as that. That is what we expect, because the angle is a symmetrical angle, okay. So, ZCG and YCG has to be same, okay. Now, next what I am interested is, I am interested in finding IZZ about the CG axis, CG of the cross section axis, okay. Now, I am going to use parallel axis theorem, okay. I know that the moment of inertia of this horizontal leg will be 1 by 12 into b plus t into t cube, that is about this z axis, that is about this z axis. Now, I have to that add this YCG CS squared the area of that leg, area of this leg, right. So, that will be plus, using parallel axis theorem, area of the leg is b plus t into YCG cross section minus t by 2 the whole square, okay. That is for the horizontal leg. For the vertical leg, I will have plus 1 by 12 t into b cube plus B into T is the area of that into, I have to look at the shift from here to here, okay. This distance would be B by 2 plus T, this entire distance is B by 2 plus T, okay. That is this distance minus y CG cross section will give me this distance in here, okay. So, that will be B by 2 plus T minus y CG cross section whole square, okay. I am not going to simplify this, I am going to leave it as it because it serves no meaningful purpose now for our discussions. Similarly, I y is for the horizontal leg, it will be 1 by 12 T into B plus T the whole cube plus B plus T into T into the horizontal shift into, I have to multiply by this distance squared, okay. That distance squared would be B plus T by 2 is this distance minus Z C G S C S would give me that distance. So, that will be B plus T by 2 minus Z C G C S will be that distance squared, okay, plus for the vertical leg, it is going to be 1 by 12, this is BD cube, instead of BD cube I have to do DB cube now because I am looking at moment of inertia about the y axis. So, it is going to be BT cube plus that area B into T into the shift, that is I have to look at this distance for the shift along the z axis, along the y axis, okay. Moment of inertia along the y axis, about the y axis I have to look at this shift, okay. So, basically that will be Z C G C S minus T by 2 the whole square, okay. In all these things it did not matter for us whether the shift was positive along the positive direction or the negative direction because I was squaring the distance. So, I always took the distance to be a positive number, but when it comes to I y z, when I want to compute I y z about the centroid, I want to compute I y z about the central axis, okay. Now, this will be the moment of inertia about the center of the cross section, which is 0 for this case, and there will be only the shifting term, right. So, it matters whether the shift is positive or negative along the x and y direction, y and z direction, okay. So, let us look what it is for the horizontal member. Let us look what is the shift for this horizontal member, okay. So, it is area B plus T into T, because the basic moment of inertia I y z about the center of the cross section is 0 for this orientation of the axis for this rectangular section, right. So, that is 0. So, I am left with only the shifting term. The shifting term would be for the horizontal leg, you add this and this as the shifting terms. So, basically now that will be y cross section C G minus T by 2 into B plus T by 2 minus Z cross section C S, okay. Now, should this be positive or negative is the question, okay. So, what happens? Both the shifts are in the negative y direction and in the negative z direction. So, negative will balance out to give positive direction, positive value, okay. Similarly, next what you have to do is you have to look at the shift in the vertical leg. So, the area of that vertical leg is b times t. Okay. Now, what is the distance you have to use? You have to use this distance b plus t minus y cgs and z cgs minus t by 2 is the distance you have to use. So, that will be b by 2 plus t minus y cross section cg into z cross section cg minus t by 2. Okay. Now, what happens? Now, both the shifts are in the positively positioned coordinate of that of the vertical member. Okay. So, hence this also remains positive. Okay. So, the shift terms are positive. So, you get IYZ to be given by this expression in here for the angle section, equal angle section. Okay. Now, so the point is IYZ is not equal to 0, it has some finite value. Now, you have to find the orientation such that IYZ goes to 0. Okay. That will give you the principal orientation of the principal axis. Okay. So, that axis would be theta p, the orientation of the principal axis will be 1 half tan inverse 2 times IYZ of the cross centroidal axis divided by IZZ or central axis minus IYY or central axis. Okay. So, for this angle section you will find that such an axis would be oriented like this. Okay. Such an axis would have orientation, this was y cross sectional CG, z cross sectional CG, and the centroid was, this is the CG of the cross section. Okay. Now, what happens is the principal axis is oriented at an angle theta p given by there, that is a clockwise rotation. So, the principal axis, this is u c g, this will be v c g cross section. This angle would be theta p, and for this angle I u v would be 0. Okay. I u v would be 0. Okay. So, for equal angle, that is how, that is the orientation of the principal axis. Okay. Thank you.